Last episode, we looked at emotion regulation and why the body has to move before the mind can follow. Today, we look at attention, the resource that makes every cognitive skill we have discussed actually usable, and why it is far more limited and fragile than most people assume. You have probably sat down to do something that required real focus and noticed that your mind was somewhere else within minutes. You pulled it back. It drifted again. You probably blamed yourself. Today, I want to show you why that drift is not a personal failing. It is the default output of a brain that was never designed for the kind of sustained voluntary focus that modern life demands. This is MindScope, where we turn the science of everyday behavior into tools you can actually use. Today, the science is attention, and the core idea is this. Sustained, voluntary attention is evolutionarily recent, metabolically expensive, and easily hijacked by systems that are much older and faster. The modern environment is specifically engineered to exploit exactly those vulnerabilities. Understanding the architecture of attention gives you a principled basis for protecting it. By the end of this episode, you will understand why attention drifts, what it costs, and 2 evidence-informed practices that restore it without requiring willpower. To understand why focus is so fragile, you need to understand what the brain is doing when it is not focused. And the answer is more organized than most people expect. The neuroscientist Marcus Raichle and colleagues identified a large-scale brain network that becomes most active when a person is not engaged in a demanding external task. They called it the default mode network. It is not a network of idleness. It is a network of internally directed thought, self-referential processing, planning, social cognition, mental simulation of future scenarios, and memory retrieval. It is, in a real sense, the brain doing what it evolved to do when the external environment does not demand immediate response. When you sit down to do focused work, you are asking your brain to suppress this default network and sustain activity in a different set of regions associated with external attention and executive control. That suppression takes active metabolic effort. It competes with one of the brain's most deeply established modes. This is not a design flaw. A brain that was always fixated on external tasks would be a brain that never planned ahead, never simulated social dynamics, never processed the past to inform the future. The default mode is valuable, but it means that sustained focus on a single external task is genuinely working against a strong competing tendency. Building on this, a large experience sampling study by Matthew Killingsworth and Daniel Gilbert at Harvard gave participants smartphones that contacted them at random intervals throughout the day and asked what they were doing and how they felt. The results were striking. Participants reported that their minds were wandering, not on the current task, almost half the time across all activities measured. And here is the finding that landed hardest. A wandering mind was an unhappy mind. People reported lower happiness when their minds were off task than when they were on task, regardless of what the task was. Mind wandering predicted unhappiness, and crucially, it predicted it more strongly than the activity itself did. So the default state is not focused attention. The default state is mind wandering. Focused attention is the departure from baseline, and it requires ongoing metabolic investment to maintain. There is a second problem layered on top of the first. Even when you do succeed in directing attention voluntarily, that capacity fatigues. Rachel and Stephen Kaplan, environmental psychologists at the University of Michigan, developed what they called attention restoration theory to explain why people reliably report feeling cognitively refreshed after time in natural environments. Their framework draws on the distinction between 2 kinds of attention. Involuntary attention is captured effortlessly by stimuli that are inherently interesting. A sudden movement, an unexpected sound, a novel face. It does not require effort because the environment does the work. Directed attention is the voluntary, effortful kind that modern cognitive work demands. It is the attention you use to hold a problem in mind, resist distraction, and persist on a task. The Kaplans propose that directed attention operates like a muscle with a finite working capacity. Sustained use depletes it. When it is depleted, the ability to concentrate, suppress distractions, and inhibit impulses all decline. They called this state directed attention fatigue. The concept maps closely onto what Daniel Kahneman described in his 2-system framework of cognition, where the deliberate, effortful system draws on limited cognitive resources and is easily disrupted when those resources are exhausted. Kahneman's work on cognitive load and decision quality showed that sustained cognitive effort degrades performance on tasks requiring judgment and self-regulation. There is a separate line of research, sometimes called the ego depletion model, that proposed self-regulatory capacity operates like a limited resource consumed by use. That model has faced significant replication challenges, and the specific mechanism originally proposed has not held up under scrutiny. The honest account is that the resource model of self-regulation remains contested. But the broader observation that sustained effortful cognitive control is not indefinitely available and that its capacity varies with prior demands is consistent with both the Kaplan framework and the cognitive load literature, which are on firmer empirical ground. So here is the question that should be open now. If directed attention fatigues through sustained use, and if the brain's default is to wander rather than focus, what actually restores the capacity? The Kaplans proposed a specific answer. And when you see what it is, it makes immediate sense given the architecture we have just covered. The Kaplans argued that directed attention is restored by environments that engage in voluntary attention effortlessly, and that require no directed effort to process. Natural environments are the canonical example. A forest, a body of water, a park, an open landscape. These environments contain what the Kaplans called soft fascination, stimuli that capture attention gently, without demanding cognitive effort. Moving water, clouds, birdsong, shifting leaves. The directed attention system gets genuine rest because it is not being called on, while the involuntary system handles whatever the environment offers. Empirical support for this came from a series of studies by Mark Berman and colleagues who tested attention and working memory in participants before and after walks in either a natural environment or an urban environment. Participants who walked in the natural setting showed meaningful improvements in attention and working memory performance on return. Those who walked in the urban setting did not show the same recovery. The urban walk involved ongoing demands on directed attention, traffic, noise, other people, information, while the natural walk allowed the directed system to rest. The single most evidence-backed way to restore directed attention, according to the literature on attention restoration, is exposure to natural environments. You do not need a wilderness. Research suggests that even brief exposure to genuinely natural elements, a park, a garden, a view that contains trees and open sky, produces measurable restoration effects. The second practice follows from the mind-wandering finding. Killingsworth and Gilbert's data showed that mind-wandering is not equally costly in all contexts. The unhappiness associated with it was linked to unintentional, uncontrolled wandering, where the mind drifts without the person choosing it. Intentional mind-wandering, the kind that happens during a deliberate mental break or during low-demand tasks, is different. Scheduling genuine cognitive rest, periods where no directed attention is demanded, allows the system to cycle through its default mode activity without the friction of struggling against it. This is not the same as distraction. Distraction is the directed attention system losing the fight. Rest is deliberately stepping back from the fight so the system can recover. Together, these two practices, brief natural environment exposure and scheduled cognitive rest, operate on the same mechanism. They allow the directed attention system to Here is how to apply both practices in a realistic workday. For natural environment exposure, the evidence does not require a long walk. Research suggests even shorter exposures have measurable effects on mood and cognitive recovery. The practical rule is, when you notice that concentration has become effortful and errors are starting to creep in, the most efficient use of 10 to 20 minutes is time outside with natural elements rather than a different screen or a more stimulating indoor environment. The goal is involuntary attention, not more directed effort. For cognitive rest, the principle is to treat breaks as genuine disengagement rather than reduced engagement. Checking a phone, switching to a different task, scrolling, these are not rest for the directed attention system. They are lower-stakes demands on the same system. A genuine rest break involves something that does not require directed effort, quiet, a short walk, a simple physical task, or deliberate unstructured time. Even 10 minutes of this between focused work periods supports recovery better than the same 10 minutes of low-grade stimulation. If you find that sustained concentration has become significantly impaired and these approaches do not help, it is worth speaking with a healthcare professional. Persistent attention difficulties can reflect a range of underlying conditions that are treatable and worth taking seriously. Here is the whole framework in one breath. Your brain was not designed for sustained voluntary focus. Its default mode is internally directed mind wandering, which is active nearly half of waking life. When you override that default with directed attention, you draw on a depletable capacity. The modern environment is engineered to capture involuntary attention constantly, which prevents directed attention from recovering. The two evidence-informed practices that address this are brief natural environment exposure, which engages involuntary attention without taxing directed attention and allows genuine recovery, and scheduled cognitive rest, genuine disengagement rather than reduced stimulation, which serves the same restorative function. The insight is that protecting attention is not primarily a matter of willpower or discipline. It is a matter of understanding the architecture of the system and giving it the conditions it needs to recover. Work shorter focused intervals with genuine recovery in between. Step outside when the concentration starts to slip. That is not laziness. That is working with a biological system that has real limits. If this gave you a more accurate model of your own attention, consider subscribing. The next episode looks at something that directly extends this one. Why some goals sustain effort over months while others dissolve in the first week, and what that difference reveals about how we motivate ourselves. Before you go, one question. When your attention drifts today, what does it drift toward most often? Tell me in the comments. The pattern is more informative than most people realize.